19 is a prime that is the sum of the cubes of two rational numbers. 37 is also the sum of two cubes. So what about 73? It turns out that 73 is not the sum of two rational cubes, and in this video I'm going to show you how to prove that, as a number theorist would do this nowadays. What we want to prove is that this equation, x cubed plus y cubed equals 73, has no solutions with x and y being rational numbers. Or equivalently, what we say is that the curve in the plane given by this equation has no rational points. So no point on the curve, on the graph, such that x and y are both rational numbers. The first key step is to reduce this equation to a more familiar equation that is called a Weierstrass equation. And this change of variables accomplishes exactly that. With that change of variables, our equation becomes y squared equals x cubed minus 432 times 73 squared, which is what we call a Weierstrass equation for an elliptic curve. And now we have at our disposal the very rich theory of elliptic curves to prove that this new equation has no rational points, and therefore our original equation doesn't have any rational points either. And now there are two different paths we can take to prove that that equation has no rational points. We can use an algebraic approach and use the method of descent, or we can use an analytic approach and use the L function of the elliptic curve and BSD to show that there are no points. In the algebraic approach, we would first show that A, the torsion subgroup of this elliptic curve, is trivial, and also that the 2-Solmer group of this elliptic curve is trivial, and that implies that there are no rational points, that the Mordell-Weil group of this elliptic curve is trivial, and therefore that equation has no rational points. Alternatively, we can again prove that the torsion subgroup is trivial, and then prove that the L function of the elliptic curve at the value s equals 1 does not vanish. And then the Birch-Stringerton-Dyer conjecture, which is known in this case, if the L function doesn't vanish, then it would imply that the rank is 0 and therefore there are no rational points on this curve. And in fact, one can use analytic methods to prove that the value of the L function at 1 is something like 3.8, so far away from 0, so it doesn't vanish, and therefore the rank is 0 and there are no rational points. Or there is a third option, which is that we can use what's called the LMFDB, the L functions and modular forms database. In the LMFDB in particular, you can find a database of elliptic curves. So we can look up the elliptic curve we are interested in, and if the elliptic curve we're interested in is in the LMFDB, is in the database, which in this case it is, then we have a lot of data already pre-computed and proved at our disposal. In particular, the LMFDB tells me that the torsion is trivial, that the rank is trivial, that the L function at 1, the value is 3.8, etc. So out of this, I can also deduce that there are no points on that curve, and therefore 73 is not the sum of two rational cubes.